The first thing to know when we're learning about derivatives is we have to know when they're asking for us to take the derivative. So this is some derivative notation. The first one is y prime, second one is f prime of x, and if the function is expressed as g of x, then you might have to do g prime of x. And the last one is dy over dx. So these are all the different ways that they could ask you to take the derivatives. Keep in mind that certain variables can change, such as y and x, and the f and g. Next, let's try to understand what a derivative means. So here we have the graph of y equals x squared. And we'll learn how to take the derivative later, but for now just know that the derivative is equal to 2x. So what exactly does taking the derivative of this function do? Well, the derivative can actually tell us the instantaneous slope at each point on this graph. So what do I mean by that? Let's say that x is equal to 0. If you plug in x as equal to 0 here, you're going to get that the derivative is equal to 0. So this means that when x is equal to 0, the graph has a slope of 0, which makes sense because it's a horizontal line at this point. And so we can see that if we move to the right, let's say that x is equal to 1, and we plug in a 1 into this function, you're going to get that the derivative is equal to 2. What that means is that when x equals 1, the function x squared has a slope of 2. And this makes sense because you can see that the slope is positive in this direction. What happens if you go to the left? Well, in this particular case, if x is equal to negative 1, and you plug that into the derivative, then you're going to get that the derivative is equal to negative 2. This means that when x is equal to negative 1, for the equation x squared, the instantaneous slope at that point is going to be negative 2. This also makes sense because if you look at the graph, the line is going down, which means that the slope should be negative. So just know that when you're taking the derivative of a function, that derivative will tell you the instantaneous slope of the original function. The official definition of a derivative is f prime of x is equal to limit h approaches 0, f of x plus h minus f of x all over h. Now that we have the definition of a derivative, we can use this to actually find the derivative of different functions. So let's take the function f of x is equal to 2x minus 8 as an example. So f prime of x, or the derivative of this function, would be equal to the limit as h approaches 0 of 2 times x plus h minus 8 minus 2x minus 8 all over h. So what we did here was we used the definition of the derivative, and in the first one, you're going to plug x plus h into the function, which gives you 2 times x plus h minus 8, and in the second one, you simply subtract that by the original function. That gives you the setup. And we can actually continue to simplify the top. So limit h approaches 0, and you can distribute the 2 here. So you get 2x plus 2h minus 8. You can distribute the negative sign here. Minus 2x plus 8 all over h. Now you can notice that the 2x's actually cancel out, and the negative 8 and the plus 8 also cancel out. So you're left with limit as h approaches 0, 2h over h. And here you can see that the h's actually cancel out, so that simply leaves you with a 2. This means that the derivative of this equation, or f prime of x, is simply equal to 2. So let's say you're given this table, and you're asked to find f prime of 5. But we don't have an actual function for f of x, so we can't actually find the exact derivative of it. So the best you can do is simply approximate it with the given information. So what you do is you would actually find the slope from 6 to 4, because since 5 is in the middle, finding the average slope would help you best approximate f prime 5. So you would find the slope of these 2 points. So you would get 12 minus 8 over 6 minus 4, which gives you 4 over 2, and your answer would be 2. So even though we have the official definition of a derivative, there are other ways to actually find derivatives in a faster method. So this one is called the power rule. The power rule states that if you have a function f of x equal to x to the n, then f prime of x, or the derivative, is going to be equal to n times x to the n minus 1. So let's look at an example of this. The first one would be f of x is equal to x cubed plus 4x squared plus 9. Now, we can use the power rule on each one of these terms, and we can actually get the derivative. So the derivative would be, in this case, the n value would be 3. So we would get 3 times x to the 3 minus 1. In this case, you would have 4 times 2 times x to the 2 minus 1. And if it's a constant, whenever you do the power rule, it simply goes to 0. So you would just add to 0. The reason why is because if it's a constant, it's technically multiplied by x to the 0, because x to the 0 is equal to 1, so that's what gives you a constant. So if you're putting the power rule and the n value is 0, then you're multiplying whatever xn minus 1 is by 0, which is why any constant after you find the derivative is just simply going to just be equal to 0. Then you can actually simplify this, so you get that f prime of x is equal to 3x squared plus 8x, and another application for this is, let's say you're given the function f of x is equal to the square root of x. Well, remember that the square root of x is actually equal to x to the 1/2. And so now that we have x in this sort of format, we can apply it the power rule. So f prime of x would be equal to 1/2 times x to the negative 1/2. That would be your answer. If you wanted to further simplify this, this would ultimately simplify to 1 over 2 times the square root of x. I'd actually recommend memorizing this because the derivative of the square root of x comes up a lot on the test.